Hello again. Another example of Mitsubishi programming. This time I want to show how the palletizing task is being done. This task I will do it in two different methods. One by like first without defining pallet, and the second after using the definition of the pallet. Here you can see the positions that we have. P home, P2 is for the picking, it will pick it from here. P4, 5, 6, and 7, these are the corners of the pallet that I want to use. And let's see, like at top of the program, you can see override 30. This means that entire program will run with 30%, speed of 30%. Then I define two variable positions, one integer, and then I give value of the POB1 to be P4. P4 is this one, the dropping place. This is the first corner of the pallet. And then like after that, yeah, I give the POB1, the first P4, the first corner, and to the POB2 49 millimeter offset in X direction. X is in this direction that comes away from the robot. So this P6 basically becomes the like uh, P POB2. It's based on it's related to the P4 is given, but it would be around where P6 is 49 39 millimeter in X direction. So here. So in here I will do that. Anyway, robot goes to the first we give the value of 1 to the arm. This was the integer variable. Then we give we tell robot to go to the home position. Then we use this for loop for arm equals 1 to 8. Repeat this part of code until the next R. Next R is the end of the for loop. So entire this part from here to here will be repeated 8 times for R1 to 8. Okay. What this line is doing, that is wait for M in1 to be high. M input 1 is a sensor that is like in this part, and when the cube falls down here, it will be high. So here robot waits for this input to have the cube there. Then says move P2 minus 40. This is this one. This is in the tool coordinate system. So it is minus, it's basically 40 millimeter in like vertical to the surface of this rail. It will be offsetted from the P2. Then with linear movement goes to the P2, delays 0.3 second, closes the gripper, then delays 1 second for the gripper to like be closed totally, then moves again to the offset position linearly. This was the picking. And for the placing now, we will have first we have a output set, because we took this from we took one cube from there, and we make this signal 1 so that the next cube will slide down here, and then we go to the move to POB. POB, as you remember, it was this P4. POB was here, P4. And then the offset point, then we go linearly to the P4, then delay, hand open, and then move to the offset position after the delay. And here we have to determine where the next cube will come. So first cube came to where P4 was, then we determine where the next cube is coming. Here we will say if RV is less than 4, you remember the R was coming from 0 to 8. So we say if R is less than 4, we do that PRB equals PRB plus minus 39. So we in Y direction 49 millimeter in minus we shift this PRB from P4 for 39, yeah, 39 millimeter this direction every time 39 this direction 39 millimeter this direction. So every loop that this code is looping inside the for loop, we will shift this PRB 39 millimeter to this direction. And if the arm is less than 4, but after the 4, when it is 4, we will go to the else part. PRB will be PRB2. PRB2, as you remember, it was where P6 is. So then PRB2 will be shifted minus 39. So this will be shifted to the side. And here we end if. We give the value of PRB to the PRB and then we shift the PRB for the next time to go here. This is necessary because we have one time only told to go to the PRB and drop it in PRB. That's why we want to use the PRB. Like here, this line we put the value of PRB2 to the PRB and we shift it next time. And then here we have to reset the signal again, the signal that we have to reset it by this command. Then we go to the next arm and the loop, the for loop will continue. Now I will play this. You can see how it will work. And you can see also how the positions are, how the robot is picking and placing everything. 4 of them in here, and then the next 4 will come to the second row. And this program is without using Pallet. And next, after this is done, I will show how much shorter it will be if we use the Pallet. Okay, this was with the Pallet and different parts of the code you can see. Let me see this. I explained already. Now I deleted it and now copied and pasted new code here. This one is by definition of the pallet. Here you can see I'm defining the pallet using this pallet name. P4 is the first corner of the pallet, 5 and P6 and P7. These are 4 corners of the pallet. And I want here to have 4 4 nests, and here I want to have 2. So 4 times 2 is like a matrix. I tell that I want 4 times 2 to be my pallet, and then this one later I will show what it is. One is basically determining how in what system the counting should be when it goes to the multiple rows. If you put 1, it's becoming 1, 2, 3, 4, 5, 6, 7, 8. But if you put it 2, it will be like 1, 2, 3, 4. Up to here is the same. But next row, it will start counting from here. 5 will be here instead of here. So 5, 6, 7, 8, and again 9, 10, 11. That will happen like that. So here is the definition with the pallet, and here I'm not using offset anymore. Here I just have one PRB for dropping and one integer R is like a integer value that I will use it for telling which like which nest number to you from the pallet I want to put the cube on. If I say, for example, nest number 1 from the pallet, it will come here. Nest number 4 will be coming here, and so on. Like so, let's see. It's compiling. Okay, now let's reset and play. And you can see how it's going. Again is for loop, and every time that loop completes, I give to the next like nest number. Pay attention here. The fifth was here, sixth one is here. All of them. This is decided by this number 1 that I had here. If I make this number 2, you will see that the order that it's filling it's different. Yeah, now let's make it 2 and then compile and play it again. So the first 4 cubes are the same. Number 1, number 2, number 3, 4. But the fifth one will come to this side. Previously it came to this side. Now fifth is here. So this last number decides in what system to count it. It should be like this, or it should be like it comes here and then comes here and again, like that zigzag movement kind of. So that's it. And one more thing about this that I would say, you see there's 2 windows here. One window is for the program. Mitsubishi has this system that all the programs of the Mitsubishi are saved in 2 different files. Like in Robot Studio was only 1 file. Here is 2 files. One is for program and one is for position, and I have to save both of them. And when I want to download to the robot, I have to download both of them separately, but with the same name exactly. Okay, that's all that I wanted to see. You can see the positions again and compare it with the program, and you can analyze it, and you get what's